So the topic is vector, and the chapter is physical quantity, units, and vector. Today we have to study the vector. So first, scalar quantity. A physical quantity which is represented by its magnitude and unit is called scalar physical quantity. For example, the mass 5 kilogram. So 5 is magnitude, kilogram is unit. Number 2, which is very, very important, is the vector, and we have to study it today, is a physical quantity which is represented by its magnitude, unit, direction, and velocity is a vector. For example, it's 5 kilometers per hour in east. So 5 is the magnitude, kilometer per hour is the unit, and east is the direction. Now we have to make list of few physical quantities like scalar and vector. First, scalar physical quantities. So number 1 is the distance. Number 2 is the speed. Number 3 is the work. Number 4 is the power. Number 5 is the pressure. Number 6 is the specific heat capacity. Number 7, the voltage, etc. On the other hand, vectors, number 1 is the displacement. Number 2 is the velocity. Number 3 is the acceleration. Number 4 is the momentum. Number 5 is the moment, which is also called the torque. Number 6, electric field strength. And there are many. So these are few scalar physical quantities and vector physical quantities. Now come back to the vector. Vector is represented by number 1, length of a line to show its magnitude. So mean the magnitude is represented by the length of the line. Number 2, the arrow on the line to show its direction. And number 3, we have to write some scale to draw it. And from the scale, we can determine the unit of the vector. So the vector, number 1, the length of the line, which represents the magnitude. Number 2, arrow, which shows the direction. And number 3, scale to draw. And unit is visible over there. For example, the question is, draw the displacement of 40 meter in north. So first of all, we will select the scale. For example, 10 meter is represented by 1 centimeter. So for the 40 meter, we will draw just 4 centimeter, but in north. So these are the geographical direction. Now it's north, south, east, and west. So we will draw direction. North mean the 4 centimeter line in this direction, north line, and then arrow here. So this is your vector representing the displacement of 40 meter. Its length is 4 centimeter in north direction. Okay, now suppose this is the vector which is force, and this is 100% in the horizontal direction. Similarly, this is another force, but one vector is positive, other is negative. So this is considered positive and this is considered negative vector. Both are horizontal, but one is positive, other is negative. Next, suppose this is the force, vertical. This is another force, vertical, but this will be considered positive, this considered negative. So number 1 and the number 2 are two vectors. They are horizontal, but one is positive and 2 is negative. But number 3 and the number 4 both are vertical vectors, not horizontal. Number 3 is positive vector, and number 4 is the negative vertical vector. It means vector can be divided into two components. Vector can be resolved into two parts. So the first is called horizontal, which is x component. An x component of the vector mean it is a part of the vector which affects the object only in horizontal direction. So portion of the vector, part of the vector, which affects the object only in the horizontal direction, that is called x component. For example, force, x component fx, velocity, x component vy, acceleration, x component ax. Similarly, there is another component which is called the y component. So part of a vector which affects the object vertically is called y component. For example, fy, velocity y, acceleration y, and so on. Now vector is drawn, suppose in this direction, this is force vector, then its horizontal component fx is the vector itself, and its y component is nothing, 0. If the vector is drawn in this direction, then its fx component is the negative vector and its fy is 0. Suppose this is the vector, it is vertical, so its x component 0. If fy will be f, if this is the vector, if x, its s component is 0, and its y component will be minus f. Do remember, this side x positive, this side x negative, up y positive, and down negative according to the graph. So that's why upward y positive, downward y negative, right side x positive, left side y negative. Now suppose if the vector is not 100% vertical or horizontal, it is angled with the horizontal. So this is the horizontal line and this is the vertical line. and vector f is making some angle theta here. So this is the x line, this is the y line, and this is the origin for the graph. So we have to resolve this vector into its component. It has both components, x component and the y component. So for this, we will draw a perpendicular on either axis, either x or y, suppose x. Then this portion, this one, is called its x component, and this vertical portion is called its y component. So now this f vector is divided into two components. It is resolved into two components. According to head to tail rule, when two components are added, fx, then fy added, then the resultant of these two is the answer vector. So when two components are added according to the head to tail rule method, their answer will be the resultant vector. Now this is a right angle triangle, so 90 angle is here. According to the math, side opposite to the given angle is perpendicular, side opposite to the 90 angle is hypotenuse, and the remaining side is the base. So we can apply the trigonometry. Some people have curly brown hair through proper brushing. So number one, sine theta is perpendicular, which is Fy, divided by hypotenuse, which is F. So the formula for the Fy, it becomes F sine theta. Very, very important. Now come to the number two. Okay, the second one, cos theta is equal to base, which is Fx, over hypotenuse F. So we can write F cos theta is equal to Fx. This is second important formula. And number three, tan theta is equal to perpendicular over base. So this is the third one. And this is called the relation between both components. And the number four important, hypotenuse square is equal to perpendicular square plus base square. So we can write here hypotenuse square is equal to perpendicular square plus base square. So hypotenuse is the force, perpendicular is the Fy, base is the Fx. So F resultant vector is Fy square, Fx square whole under root. So this is the fourth important formula. Okay. Now suppose this angle is not given. This side is given, this angle is given in the question paper. So this is not the y component. This is not the x component now. So side opposite to the angle is perpendicular. This hypotenuse will remain same, opposite angle. Now this becomes the base. So base is always the x component. So this line is the x component and this line is the y component. But the formula will remain same. No change in the formula. So do remember, side adjacent to the angle is the x component and side opposite to the given angle is the y component. This is the rule. But the formula, Fy f sine theta, Fx f cos theta, tan theta Fy over Fx, Fy square, Fx square, whole under root F will remain same. So we have to remember side adjacent to the given angle. This is the side now. Adjacent to this given angle is the X component. But when angle this given, then this side is adjacent. So this will be X component. This is very, very important. So important. Line adjacent to angle theta is considered X component of a vector. And line opposite to angle theta is Y component. Number 3, X and Y component of a vector are perpendicular to each other. Mean they have angle 90 degree with each other. Now we have to apply these components. So number 1, application is component of a vector at a slope. Suppose this is the horizontal line and later we will make it slope. This is horizontal line or horizontal surface, and this surface is frictionless, no friction. This object is placed here. Its center of gravity is here. So weight is acting down, exactly downward, and the reaction of the surface on this object is upward. Now there's a rule for the weight and there is a rule for the reaction. Weight W acts towards the center of the planet. And number 2, the reaction makes 90-degree angle with the surface. So due to this 90-degree, this reaction is called normal reaction. And the normal reaction means the perpendicular reaction. So look, weight is acting toward the center of the planet, center of the earth, and this is making 90-degree angle with the surface. Now this surface is inclined and the angle of inclination is theta, so it's tilted in this direction. So this is the object, suppose this is a wooden block over here. This is the center of gravity. So the weight is acting exactly downward. But now reaction is not vertically upward because its rule is it has to make 90-degree angle with the surface. So this is the action, line of action of the reaction. So in this situation, this is upward, this is downward, this reaction upward positive, this weight is negative because in the vertical axis, this is considered positive y and this is considered negative y. Now, what is the total force, mean the resultant force when it's added? R plus minus W. So R minus W, both are equal cancelled, resultant force 0. So that's why the object is at rest, which is called the equilibrium. So the sum of two forces, 0. This is a vector sum, is 0. It means R is equal to W. So Newton's third law. Line adjacent to the angle is x component. I repeat, when this slope is tilted by angle theta, this R is also tilted by angle theta. When this R line is extended behind this angle theta, so line adjacent to the angle is WX, and this is the Y component of the weight. Reason? Because the WY and the WX both are perpendicular to each other. Look at this. Line adjacent to the angle is the X component, and then X and Y component are at the angle of 90 degree. So in this situation, this R is balanced by the WX. So we can write R is equal to WX, but this WY has no force at the back to balance it. So it means this WY force are the component, it becomes unbalanced. So there is nothing at the back because we already saying that this is a frictionless surface. So if there is no friction, so no force at the back. So this becomes WY unbalanced. So WY is unbalanced, and according to Newton's second law, every unbalanced force produces acceleration, which is equal to ma. So unbalanced force is equal to ma. It means Wy is equal to ma, and Wy is equal to W sine theta, because Fi, F sine theta. Wi, W sine theta is equal to ma. So W is mg. So we can write mg is equal to ma. Now m cancelled. So acceleration at the slope is g sine theta.